In last class, we started discussing aggregation operations, right? We discussed aggregation operations. There are three aggregation operations: reduce, fold, aggregate operations, right? So aggregate operations works on partition level as well as results of partition level, and results of partition level. Okay. So here partition level, partition level, partition level, we can apply same operations, and results of partition level we can apply same operations, or partition level we can apply different operations, and results of partition level we can apply different operations. So this is the facility of aggregation operations. Reduce and fold functions, reduce and fold operations, we can apply partition level same, results of partition level same. Aggregate function we can apply partition level different, results of partition level different. Results of partition level different. Okay, so let's see aggregation operations. So let's let's write this: importing package, creating Spark context, and setting configuration object, and setting log level, and creating some value RDD. Then I'll show one by one here. Let's start our IntelliJ IDE. So I'm changing workspace to Spark Core. So we have created Spark Core workspace, right? It's importing packages. Let's wait. So it is already imported packages. Spark Core only, right? Let's create package com.qt. Oh, yep. I opened a different workspace. That's why it is not showing. Open, and here see users, username, and desktop in this quality that I created. So Spark and Scala. Here ours is batch 3 workspace, and here let me create a new one, Spark Core. Let me add dependencies, Spark dependencies, SBT. Only core dependency. I'm adding core dependency. Oh, so we've opened module. That's why it is not created. Let me create module. Create new project, SBT. Let me select user, users, username, select our workspace, Spark and Scala, and here batch 3, workspace, and here I am creating new core and OK, and select 2.11.x, click on finish. Yes, in this window. It is created. Let's go open this SBT. Click on import package. It will create, if there is any pendings, it will create a project structure. Yep, everything is perfect. Let's add Spark core dependency. So it's updating local directories. Okay. So updated one. Once again refresh. Okay. Right click on this Scala. Click on new. Click on this package. Write com.qt. Click on OK. Okay. Right click on this one. New. Scala class. Spark core app. Spark core app 1. Select object. Yep. I'm not writing anything here. Uh, let me wait to finish this process running. Yep. Let's click on this SBT cell and here type console. So it is going to start SBT Scala prompt. SBT Scala prompt. So it started Scala cell, SBT Scala cell. Next, first I'm importing import org dot apache dot spark dot underscore means I'm importing Spark package. Next, create Spark context object, Spark configuration object, and pass that configuration object to Spark context object. Instead of that one, what I'm doing, I am passing directly. I'm creating Spark context object val s equal to new Spark context object, and I'm passing new Spark con object. Inside constructor of context object, what I'm doing, I'm passing context object, configuration object. So for this configuration object, I'm setting master name. Set spark dot and master name I'm setting spark dot app dot sorry master I'm passing local 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 master, and next one dot set I'm setting application name spark dot app dot name, and application name I am setting Spark aggregations. So it is going to create a Spark context object. So Spark context object is created. Then sc dot set log level. I'm setting log level equal to warning. So log level is set. Next, what I'm doing, I'm creating one RDD by using range. I'm creating one RDD by using range. So it will create RDD. Observe range function in Spark context creates RDD. So range function takes one starting value and ending value. It will create range between 1 to 10. It will create RDD with values 1 to 10. So if I call r1 dot count, I will get value of 9. Next, if I call r1 dot get number of partitions, num partitions. So it is showing only one partition. It is showing only one partition. Oh, yep. See here, get num partitions, we are getting only one partition. So if you use raise function without specifying any partitions, then it will create only one partition, because while creating local master here, we did not specify any number of cores, right? So by default it will allocate only one core for our Spark application. By default it will assign only one core for our Spark application. So when you create RDD, it will assign only partition only one partition. If you want to increase partition, we can go for repartition. But here, while creating RDD by using range, we can also specify number of partitions. So this one, val r1 sc dot range 1 comma 10. So starting value, ending value, it will create values between 1 to 10, and this one is incremented value, and this one is number of partitions. Let's try this one, incremented value and number of partitions. Then r1 dot count, we'll see 9 only. Next, r1 dot get num partitions. See, now it's showing number of partitions are 2. So at the time of RDD creation by using range function, we can specify number of partitions. Why we are seeing this partitions means, we are going to deal with the partition level aggregation, right? Partition level we are performing operation, and results of partition level we are performing operation. That's why I'm showing you how to increase number of partitions while creating RDD using range function. Okay. So I said aggregation operation should be satisfied with the cumulative law. We discussed this one. Yes or no? So aggregative operations must be satisfy cumulative law, because here we are creating multiple partitions. So we don't know which partition executes first. Yes or no, team? This is parallel processing operation. This is parallel processing operation. Spark performs parallel processing operation. So whenever you apply aggregation operations, we have multiple partitions. Assume 10 partitions. Which partition first executes first, we don't know. In which order partitions are going to execute, we don't know. So if you run same application multiple times, we don't know order of partitions execution. So finally, after combining the results, result should not be changed. Result should not be changed. Whatever the order of partitions execution, whatever the order of partitions execution, result should not be changed. So it should satisfy cumulative law. Okay, let's first discuss about reduce function. So reduce function takes input as another function type. So first point, reduce function takes parameter is another function type. Okay, which take two elements of RDD element. So every time it will take two elements of RDD, returns the element of same type. Means inside this function type, we write some logic. That logic returns, what? Result is same type. Means after performing, for example, you passed two parameters, A and B. A type is int, B type is int. Finally, after performing operation, it will return result is int type only. So here, function return type means elements, return type of the elements is same type means, so whatever the type of elements we pass, return type we get the same type. Okay, let's see the syntax of reduce function. Reduce function takes parameter as function. Reduce function takes parameter as function. Okay, so here let's see, I'm creating one list, and this list contain 1 comma 2 comma 5, 1 comma 2 comma 5. So we are creating RDD, then RDD dot reduce function I am calling. So I said this reduce function takes function as a input, function as a input. This is anonymous function, right, team? Did you remember anonymous functions in Scala? Sorry. So this is anonymous function, right? For anonymous function, I am providing implementation. Hello, team. Yep. So first it will take 1 and 2. 1 stores in X and 2 stores in Y. So 1 plus 2, 3. And finally result is going to store in X. And Y it pass next value, 5. So 3 plus 5, 8. Finally result is going to store in X, and final output returns to variable sum. Okay, let's see this implementation first. Later we clearly see the partition level operations. Okay, so we'll create multiple partitions and we apply same reduce function. I'm creating val rdd 1 equal to sc dot parallelize, let me see spelling, let me start parallelize list of 1 comma 2 comma 3 rdd 1 is created. Let's rdd 1 dot count. So we have three values, right? We get count is 3. RDD 1 dot collect dot for each println. So it is printing values. Now what I am doing, val sum equal to RDD1 dot RDD1 dot RDD1 dot reduce RDD1 dot reduce x comma y implies x plus y. Okay, then oh, I passed 1 2 3, not 1 2 5. That's why I got output is 5. If I display sum, I'll get output is 6. Correct, right? Okay. So let me create a range with this partition val r1 sc dot range 1 comma 10 and increment 1 partitions are 2. So val r1 equal to sc dot range 1 comma 10 increment by 1 and number of partitions are 2. R1 dot count R1 dot collect dot for each R1 dot collect dot for each println. So we got see first partition, these are the values 1 to 5. Second partition, these are the values. So we have two partitions. Partition 1 1 2 3 4 5. In partition 2 we have 6 7 8 9. So it clearly showing partition values. Okay, first partition value, second partition value. Now what I am doing, val sum equal to r1 dot r1 dot reduce and x comma y implies x plus y. Then see the output. So output is 45. So how it performs output is, see here, first it will take 1 plus 2, right? So result equal to 3. Next 3 plus 3, result equal to 6. 6 plus 4, result equal to 10. Next 10 plus 5, result equal to 15. Okay, first partition output is 15. Next coming to second partition here, 6 plus 7, what is the value? 13. 13 plus 10, 13 plus 8, 13 plus 8, what is the value? 21, right? 21. Okay, next one, 21 plus 9, 21 plus 9 equal to 30. So here this is 15 plus 15 plus 30. So finally we get 45. So we got output is 45. So here reduce function reduce function applies. This is partition level uh, aggregation, right? This is results of partition level. So partition level it applies the same logic, and results of partition level it applies same logic. Results of partition level it applies the same logic. So the order of computation of partition is not same always, because we have a two partitions. In other cases, if data is huge and we create multiple partitions, right? So order of partitions may be, order of evaluation of partitions may be different. In that case, results should not be changed. So this is the main important point of aggregation functions. Aggregation functions. Okay, I'm stopping now. Is it possible tomorrow from 8 to 10 team? Okay, so tomorrow I'll spend 2 hours, and tomorrow we'll decide Saturday and schedule a plan. Okay, so tomorrow I'll ask Bobby to schedule meeting 8 to 10. 8 to 10. Okay, tomorrow we'll spend 2 hours. Day after tomorrow and Sunday, uh, we will plan according to. So we discussed 2 to 5, right? If possible, we'll spend morning also. If possible, we'll decide that one tomorrow class. Okay. Yep. Thank you. We'll meet tomorrow and we'll continue aggregation part.